There we go. Hello, everyone. Happy Thursday. I hope you're having a good afternoon so far. Welcome to today's presentation. Our presenter is Cambium, and the actual presenter is Zach Tolbert here, and he is presenting how sustainable wood choices drive climate impact. So, a few things to note about this presentation before we get going into it. The first thing is that this is AIA approved, so you will receive one learning credit from today's presentation. If you weren't able to drop that registration number in the registration link, I will drop a form to fill out in the chat. So that's to ensure that you receive credit for today's presentation. The second thing to note, we'll have time for questions at the end. Please feel free to use that Q&A button or the chat button as well, and we'll get to them at the end of today's presentation. And then the last thing I want to show you guys, and Zach, if you wouldn't mind stopping sharing your screen for me, is where to find Cambium's amazing products and photos on Acelab. This will be the second link I'll include in the chat today. And this is their brand page here. Some really great information like how to connect with someone from the team here for direct project or firm standard expertise, as well as their products here. These products here will give some cut sheets and any certifications and stuff like that. And then finally, here's some really great inspiration pictures. I know a lot of times clients ask for those inspiration imageries. You can pull from right here. Now I'll stop sharing my screen and I will let you take over, Zach, whenever you are ready.
Awesome. Thank you, Alyssa. Thank you, everyone, for joining. My name is Zach Tolbert. I'm a landscape architect by trade, been in the wood world for many years. Today, we're going to talk about how wood choices can improve your sustainability and the little details that make a big difference. So we'll talk about overall reducing embodied carbon in the built environment, how your sourcing decisions can make a big difference, and as well as your specifications. We'll look at wood through a carbon lens and talk about some innovation in wood. So, as I just stated, understanding the carbon equation of wood, leverage thermally modified and other innovative tools, evaluate climate cost of tropical hardwoods, which is a big one, integrate carbon goals into specifications, and design for impact and performance. So in the US, there is a 110 million ton waste problem, and that is just in US cities. We lose 36 million trees every year due to disease, death, natural disaster, and development. 90% of that either gets chipped and taken to a landfill or it's burned on site. Costs cities almost $1 billion a year to deal with that, and that is just the tipping fees at the landfill. That doesn't include the labor and cost to move that material and deal with that. Those 36 million trees just from US cities represent about 40 billion in usable lumber, which is 3.5 times what we imported last year. So the system is broken. We are throwing away copious amounts of good usable material and cutting down forests to meet the demands that we have in the building industry. So there is a huge opportunity to give new life to fallen trees that would otherwise go to waste and really reduce your carbon impacts in the built environment. Because building construction represents over 37% of global CO2 emissions. While using wood is a great resource, not all wood is the same. And if we were to capture just those 36 million trees from US cities, we could reduce about half of all passenger vehicle emissions per year. And as we all know, AIA, ASLA, the MEP, every structural, they're all moving, every organization is moving towards zero carbon emissions, net zero, by somewhere between 2030 and 2060, depending on the organization. And so the things that we'll talk about today can help you accelerate that and move there quicker. There are domestic solutions that exist to solve some of these problems. So before we get into that, just want to step back and look at the wood industry in North America from the last few hundred years. So when European settlers arrived, we saw wood as this unlimited resource until it wasn't. Old growth trees as far as the eye could see, which probably wasn't very far because those forests were massive, and beautiful old growth trees, really durable, really great building materials. And so we started cutting trees, and we cut all of them across the Northeast, over to the Great Lakes. No tree was safe from the use here. And it wasn't until the late 1800s when Congress launched the Department of Agriculture to actually start to monitor forest health, because the trees weren't growing back nearly as fast as we were cutting them down. And it wasn't until the turn of the 1900s that we actually, as a country, started implementing reforestation practices. And unfortunately, we were cutting those big, beautiful giants across the West Coast that, in my personal opinion, probably should have been left there. But the wood species does matter a lot. And I know a lot of people for the last 30 years have saw tropical hardwoods as this unbelievably dense, long-lasting product. But the species matters in terms of sustainability. And I don't want us to make the same mistakes that we made the last few hundred years in North America. Same thing is happening in Brazil right now. So let's move away from that. So in the decking and siding market in the US, we're looking at about $20 billion a year. But I would venture to say close to 70% of that is unsustainable materials, either composites or tropical hardwoods or chemically ridden wood. And we have better options than that. The truth about exotic woods is they are not as amazing as everyone has made them out to be. I get clients who say their clients are pushing for epay because it'll last longer than anything. Well, where did they get that data from? Because I've seen lots of places where that wood failed in less than 10 years. But there's a huge chance that all of that tropical hardwoods are illegally harvested, which means they are cutting down the rainforests, which are home to indigenous peoples in Brazil. So their lands are getting stolen, their livelihoods are going away, and those rainforests don't grow back as they once were. Finally, Ipe and Kumaru have made it onto the CITES Appendix 2 red list. So that means they are one step away from critically endangered. So they, starting this year, are going to be significantly more regulated in terms of exporting, limiting the amount that can be exported. So we're going to see a massive shortage, finally, in the market with these not so sustainable woods, because Ipe is actually a keystone species. So even if you went in with a helicopter, cut the base of the tree and lifted that tree away, not disturbing any of the forest floor, that whole ecosystem around that tree is going to collapse within 5 years. They are the keystone species that hold all of that ecosystem together. They're also really slow growing trees. And they don't produce that much wood when you mill a gnarly old growth Ipe tree. So you take that old growth log, put it on the mill, turn it into a square cant to make boards from it, you're already losing 60% of that biomass. When you grade that for export quality, looking for lengths longer than 8 feet, you lose another 75%. So you get a very small amount of yield from each Ipe tree that's cut. It takes about 2.5 acres of rainforest to make a 150 square foot deck using 8-foot lengths or longer. This is to scale. Pretty shocking what our clients make us do to get them an elegant deck. You scale that up to a municipal level project, a boardwalk, 3,000 linear feet long, you're looking at close to 260 acres of rainforest just for that one project. Not to mention all the carbon from emissions from transportation and all the other negative effects on the planet that this has. So really would be great if all the architects and landscape architects and everyone in the design community would band together and force our clients to stop requiring ipe and coumarin. In fact, you actually have a lower carbon footprint going with a precast concrete paver than you do putting in an ipe deck. This is why the species matters, and not all wood is good. This is a 10-year-old deck that I found on my sales journeys over the years. This was on its 10-year anniversary. Pretty horrible condition to be the most durable wood for an exterior deck. So let's talk about the sustainable options, which, full transparency, I used to represent Akoya and Kebony, and I'll still say they are far better than cutting down the rainforest. But Lunawood, Thermery, Akoya, Kebony, they're global travelers. Akoya and Kebony's radiata pine is grown in New Zealand, modified in either Europe or the United States. Thermery is cutting down US grown ash trees, shipping it to Estonia to be thermally modified and shipping it back. And Lunawood is using a Norway spruce and then shipping that to the US. So we're looking at 5 to close to 20,000 miles by boat before it even gets unloaded and shipped across the US to your job site. And if shipping were a country, we're talking about the 6th largest greenhouse gas emitter globally. So let's really make some effort to use domestic species that we have readily available. We really need to, as an industry, specify products that utilize domestic and modern supply chains, utilize technology to our advantage to simplify sourcing, improve pricing, and deliver better outcomes for the people and the planet. Utilizing a circular economy model whenever possible is always your best option. So utilizing fallen trees, getting that to local sawmills, local manufacturing into the built environment so that that carbon can be embodied for decades to come is always going to be a better win. And then planting new trees for future generations. Compared to composites and even traditionally harvested woods, salvaged wood has a far lower carbon footprint than freshly cut material out of the forests. That is avoided carbon because of the alternative fate that this material would have gone either into the waste stream or into the burn pile. So let's talk about specifying wood sustainably. It really comes down to how that wood is milled at the very beginning. So a lot of folks, I've seen a lot of cut lists and spec sheets that say rift sawn FAS grade cedar, rift sawn FAS grade white oak. Always with those two qualifying specs of FAS and rift sawn. Those two details hold so much power in the actual sustainability of the wood you're sourcing. The yield from a rift sawn log is far lower than even quarter sawn, much less plain sawn. So if we can expand our vision of what this wood should look like and welcome in a little bit different, more varying grain patterns, you can really improve the yield of the log and thus the sustainability of that spec. FAS selects 1 common, 2 common. Those are the standard grading for hardwoods. FAS, you're only getting about 10% from every log, and that's on average. Some logs produce 0 FAS grade material. Selects a little bit more. 1 common, you're really starting to get into a big majority of that log. So if you can expand your spec from FAS to 1 common and better, utilizing all 3 of those top 3 categories, you're pushing 65% of the log right there can be utilized. Because right now in the US, over 50% of the hardwood trees that are cut and processed through mills go to low-grade uses like pallets. Why are we sending, selects and one common material that can easily be fit into a high-end design that's going to make pallets? That's an unacceptable situation here in my book. So let's look at it, a typical spec. You're looking for white oak, FAS quarter sawn, 6-inch nominal, or rift sawn. If we're going rift, a 3,000 square foot wall, 1x6 FAS grade rift sawn white oak. Rift sawn, you're getting maybe 50% yield. FAS grade, 15% yield. The 6-inch nominal, the wider the board, the less yield you get from a log. You end up with this one spec of 3,000 square feet, you're going to need 300 logs to fulfill that order. And you're only using the top 4% of each log. So 96% of those 300 logs don't have a home. And if you've cherry picked the best boards out of all those logs, it's harder to find a home for that. And so there's a high probability that 96% of these 300 logs are going to go to things like pallets that are a very, very short-lived product for that wood and that carbon. 4% of those logs. So if you were to be a little bit more carbon smart with your specs and open it up to one common and mixed grain and mixed width, you're looking at 60% yield from those logs. That other 40% goes to lower grade uses. That is a perfectly acceptable use for the two common. You're also going to reduce the cost. So not only are you going to be more sustainability focused, you're also going to have a lower cost for your client. There's also a lot of innovation in wood that can lead to impact. Thermal modification is not a new technology. It's been around for 30, 40 years in Europe. Go figure. Most of the sustainability focused building trends start in Europe and then eventually make it to the US. But thermal modification is a really brilliant way to turn something like red oak that would start to rot in 2 to 3 years in the exterior environment. After it's thermally modified, it has a 20-year warranty, 30, 40 plus year lifespan, depending on the microclimate of where the project is and how it's maintained. But you're 10xing the lifespan of that wood at a very minimum just by running through a thermal kiln. So it is a chemical-free process, just heat and steam, takes the temperatures over 200 degrees Celsius, makes the wood more hydrophobic, bakes the sugars and starches out of the wood so there's no food for insects, fungus, and mold to go after, and makes a beautiful, beautiful, rich chocolate brown product. So in the thermal kiln, it takes about 2 days to do this, and it's a very specific set of technology. The kilns are very expensive and very technical to run. This is definitely dumbing this down a bit, but you ramp the wood up to around 200 degrees Celsius, taking the already kiln dried wood that would be at a moisture content of 12 to 15%, basically takes it down to 0%. The thermal modification happens at the peak. It transforms mechanically the cell structure to make it more hydrophobic, so water does not make it shrink or swell nearly as much. And it's done in the void of oxygen, so displaced with steam to keep the wood from combusting at that high temp. And then there's a very specific cool down period that reintroduces, because at the peak, the wood goes down to basically zero moisture content, which is not really a sustainable building product. So as it is reconditioned down in the cooling process, it gets to, on average, 4 to 6% moisture content. Some climates, that'll end up being 6 to 7. So again, 100% chemical free. It enhances the appearance, makes red oak, which is an undesirable, naturally looking wood for most clients these days, and turns it into this rich, beautiful brown color. It's decay resistant. It's way more stable, and the cellular structure under a microscope looks completely different. It looks like 350-year-old old growth trees, and this is from a tree that was probably 60 years old. So comparing durability, thermally modified ash, I would actually put oak, thermally modified oak, right here in the same class. Ipe and Kumru were at the top of the list, but now thankfully they're on the CITES list as an endangered species. That is basically off the table, and that is the out that we all needed to get our clients to drop the fight on pushing for this unsustainable material. Even though we knew for the last decade, 15 years, that it wasn't a sustainable option, we had nothing to push back to clients about. But now you can confidently say that it is recognized globally as an endangered species. Working your way down, thermally modified pine is a great option for more of the projects that need to VE. Fantastic cladding product, fencing. It's a little bit softer, so it's going to get some wear as a walking surface, but if you can accept that visual degradation, it's a fantastic decking product as well. You've got naturally rot-resistant cedar, which is a great option as well. And then at the very bottom, pressure treated, which now that they've removed the arsenic in 2004, you're only going to get maybe 10 years, 12 years lifespan out of that. So if you are doing a deck and you need pressure treated substructure, make sure you're putting joist tape on the top of those joists. That should add 50 to 100% of lifespan to that substructure and make that not the weakest link and failing halfway through the lifespan of your deck boards. Weathering, especially with thermally modified woods, is going to be pretty standard. Yes, it's a rich, dark chocolate brown when it's installed, but like all wood, it's going to weather to a gray patina, which is elegant and lovely and will continue to be that color for the lifespan of the wood. But if you're working with a client that says, I want this rich brown color, but I want zero maintenance, those things don't align. They're either going to have to do maintenance to maintain the color or accept that patina. So my advice to all specifiers is when you're rendering your project, make sure you're rendering it accurately with that weathering process. If they want it to be zero maintenance, make sure you show them that gray color at the beginning and think about roof overhangs and other shadows that will impact that weathering process, and make sure you render it accurately so there's no surprises. It'll be a much better outcome for both you and the client in the long run. Thermally modified wood, yes, it can be a bit more brittle than an unmodified wood, but as I mentioned before, that extension of the lifespan of 10x or more is worth it. So it's still going to be far easier to work with than super dense tropical hardwoods. So you don't need special drill bits or saw blades. You should still pre-drill for a really great install, and handle it a little differently, but it's going to be lighter weight, so you can carry more boards on the job site than you can a tropical hardwood. So it should significantly reduce your installation costs going with thermally modified over tropicals. But works with hidden fastener systems, especially on lower traffic areas. That slide I showed earlier of the failing Ipe deck used a hidden fastener clip system on a super high traffic public deck. If you've got a situation where you're going to have that much foot traffic and also hand carts rolling equipment around for events, I tend to steer away from the hidden clip system because you're creating a vulnerable spot on the side of every board. So face fastening, high traffic decks is definitely the way to go. There's also clip-in rail systems, but an easy pre-drill, get your lines straight with a chalk line that just has water in it. So you snap a water line, pre-drill all your holes, put your fasteners in, and if your fasteners are in a nice orientation, that can actually add to the aesthetic of the deck rather than take away from it. Finishing is also highly recommended. I like to, even if the client wants the wood and welcomes the wood weathering to a silver patina, I still recommend installing it with a clear UV, with a clear oil protectant to allow that wood to acclimate more naturally into its new home. Just allows that acclimation process to be more gentle on the wood, a little less checking at the ends and through the boards. If you want to maintain that color, you'll want to make sure that you've got UV inhibitors, aka color pigment, in that oil. That a clear oil is not going to block any UV, so that wood is going to weather pretty quickly. But if you include some color tint in that finish, you will be able to maintain that rich color for years to come. And depending on the orientation, decks are usually a 1 to 2 year maintenance cycle. Wall cladding installs are more of a 3 to 5 year maintenance cycle. But penetrating oils are, for the most part, pretty DIY friendly for maintenance cycles. So whether that's a homeowner or a commercial project, it's a pretty easy process to refinish those every few years. We got this is a beautiful all thermal oak install, cladding, decking, stair treads. I like to. They really wanted that mid-century modern look, so these are actually much narrower boards in some sections. So you've got some 1x6, also some 1x2 tongue and groove to accentuate that vertical lines. And this project, utilizing salvaged wood, we salvaged almost 11,000 board feet, and which is the equivalent, because of that avoided carbon, 643 gallons of gas. So salvage wood really does have a high impact and can make a big difference in your carbon data. Another beautiful thermal pine install, which claim to fame here was about 100 miles worth of cladding. Massive, massive project across 26 buildings on 9 acres. So can be used at scale and can be a beautiful product. Now, this is thermally modified ash. This dark section up here by the window, that's actually a Shishugibon, which is another treatment that can be done on thermally modified woods to give you that charred aesthetic. Edge grain flooring is another innovation. So this is a product that allows you to utilize wood in really small increments. This manufacturing line actually is able to salvage wood from the production line. So when you're milling a log, I was talking about the waste earlier. A lot of that waste is boards that are 3 feet, 4 feet, 5 feet long. In hardwoods, those don't meet grades from the NHLA grading scale. So that becomes trash. There's no value to that from an industry standpoint. However, you can turn that into an edge grain flooring product. We can salvage boards as short as 3 feet and 2.5 inches wide. So wood that would otherwise go to heat the boilers to dry the next load of wood in a kiln can now be turned into a 100-year flooring product. And it's had great success in the Portland, Oregon airport. Really beautiful, really durable case studies and maintenance reports show that it's actually less maintenance than terrazzo, and certainly feels much warmer and more welcoming to enjoy while you're at what would normally be a stressful environment. Mass timber is another great use of salvaged wood, and wood in general. But again, where that wood comes from plays a direct impact as to the sustainability of that. So the ability to integrate salvaged wood into a mass timber building can only further reduce your carbon footprint of that project. Another cool new innovation is this product called Superwood. About 144 patents out of the University of Maryland went into making this, and it is taking a poplar, which you see here at the bottom of this list, 540 on the Janka scale, modifying that, compressing that into a 5/16 inch thick board with all the cellular structure and wood fiber just condensed, all those air pockets and basically nutrient transfer tubes, the cellular structure of wood is compressed, and the density is now 4,800 on the Janka scale. So 25% denser than Ipe, and just a fantastic way to turn a low value hardwood that is plentiful and widely available in the US into a super dense, super durable product that will have a Class A fire rating. It's moisture resistant, 3 times denser than oak, termite resistant, fungus resistant, very stable, and will allow you to have a Class A fire rated wall cladding product while using a rain screen, which is usually counterintuitive to a Class A product. Then we've got get into EPDs. I am grateful as somebody who's been a sustainability nerd for 15 years. I'm grateful that that EPDs and LCAs have taken widespread adoption. However, you got to look at what's actually in that EPD and make sure you're still comparing apples to apples. You know, a product that's made out of petroleum-based products can still get an EPD, but what it says in the EPD can be not great for the planet. So make sure, just use a little bit of common sense and make sure you're choosing the right materials, not just because it checks the box and has an EPD, but because it is a very sustainable product. And not all EPDs compare all of the same things. With salvaged wood, you're actually going to potentially have some issues where you can't get an EPD because, or it's not going to show the same data that as impactful data because it's comparing A1 through A3 manufacturing impacts, and it's not including and factoring in some of the avoided carbon benefits of salvaging wood instead of cutting down forests. Salvage wood can also create a lot of lead points and contribute to a lot of lead points. So a couple different sections looking at 9 potential points from using salvage wood on a lead project. Salvage wood's also great on living building challenge projects as well. They are the first to accept FSC or salvaged, which is a fantastic advancement for the sustainability world. FSC is great, but that's really just it's a paperwork chain of custody. It doesn't actually require digital stamps at, tracking the trucking of where this came from, where it was processed, where secondary processing, kilns, all of those things. So a more potent chain of custody is always welcome, and salvage wood can usually justify that. Again, all of our industries are moving towards zero carbon and net zero, decarbonizing the built environment. Salvaged wood is one of the best places that you can up the game there. It's also a lot of tools for measuring embodied carbon. This is Certainly not an all-encompassing list, but the EC3 tool, Tally, one-click LCA, there's a bunch more out there. C-Scale is a fantastic group. But utilizing these these products and uh, tools in your early project design can go a long way. Because really, sustainability does start with supply chains. And so, yeah, let's make some better choices. Let's utilize salvaged wood as much as possible and make a bigger impact on this planet that we're building on. And that's it for today.
Thank you so much for that presentation. I have a few questions that came in through the chat to me, and I'm going to launch this webinar poll. So feel free to fill this out while we get into just a few questions here. And this is a great way to connect with Zach and Melanie after today's presentation. And I believe Melanie just added something into the chat as well. Can you share more about how different species respond to thermal modification? Does it work equally well on all wood types?
It does not. There are definitely certain species that work better than others. The industry is evolving. There are in Europe there are more available species than there are in the US. But it's always good to check and happy to dive into that deeper if you want to shoot me an email.
Okay, perfect. This next question I have here is, can you share a case study showing measurable carbon reductions achieved through the strategic wood material choice?
Yes, I can. I don't know if I have too many available right this second. That residence that I showed that avoided 600 and what was it, 23 gallons of gas was one. I've got lots more of those that I can share. I just don't have them accessible right this moment.
Yes, I believe that was Mark or someone who asked that question. Feel free to fill out that information in this webinar poll, and then you guys can connect after today's presentation as well. That seems like the best way that you
Yep.
can shoot them over some exact examples. And then how do different wood treatments and finishes affect the overall carbon footprint? Sorry if we missed this.
Oh, no problem. That's a really great question. So there is a measurable amount of energy required to thermally modify wood. So it's not it definitely does change the equation in terms of the energy usage to get this product. However, taking a underutilized product or wood species like red oak that doesn't have much commercial demand and would only last for 2 to 3 years in the outdoor environment, adding that extra energy to thermally modify it, which gives it a 20-year warranty, 30+ year lifespan, I would argue all day long that that is a worthwhile investment in energy use to make that product 10x longer lasting.
Perfect. Thank you. And then we've got another question here from Fariba. Do the finishes meet ASTM E84 requirements?
Is that fire rating or is that, I don't know that requirement off the top of my head, but I'd be happy to get you that information. If you want to shoot me an email, we can offer, and a lot of these woods do have a fire treatment that is possible to get to a Class A rating, which I didn't cover in this presentation.
I believe it is a fire rating, but I'm not sure exactly about the specifics. So
Yeah,
you guys can
please
always.
email me and I will get you all the information and we can take this offline.
Awesome. Okay. That is all the questions for today. I'm going to give everyone just a second. Oh, perfect. Responded, will do. Thanks. Okay. I'm going to give everyone just another second or two to fill out this webinar poll. Zach or Melanie, do you have any final closing thoughts or anything else you'd like to share before you guys connect offline?
Thank you all for joining. It's a pleasure to be a part of Acelab and stoked to help this community grow and be more create more value for all the members.
Awesome. That was a super insightful presentation and very interesting. So thank you, Zach, and thank you, Melanie. I hope you have a good rest of your day and a great weekend coming up.
Thanks, y'all too. Take
All right.
care.